Example 10, Chapter 6. In the refrigerator shown in this picture are 134A as refrigerant, working fluid, the mass flow rate through each component is 110 kg/s, and the power input to the compressor is 5 kilowatt. The following state data are known using the state notation of the picture 1 at point 1, P1, the inlet to the compressor, cold vapor, and P second outside the compressor and inlet the condenser refrigerator. Point 3, X saturated liquid, and T4 expansion and entering cold liquid, minus 25 degrees centigrade. Calculate the quality and the evaporator inlet. Inlet. Let me start with part A. Quality in at the evaporator inlet. Consider this picture. Evaporator quality. The quality is at inlet, can be calculated at point 4, which after expansion valve. Expansion valve have the relation for H3 equals to H4. H3 is a warm liquid and H4 is a two-phase. For our A from the tables, H3 equals to HF at temperature T equals to and is kilojule on kilogram. The table B, I think B5. Let me check. B5 1. Now we can calculate H4 equals to H3 equals to two-phase flow at point 4. T equals to minus 25 degrees centigrade. Again P5 1 H3 equals to HF at T equals to minus 25. From the tables, you can check with tables if you have X multiply HFG, which is X can be calculated and is inlet evaporator. The part B is the rate of heat transfer to the evaporator. The rate of heat transfer transfer to the evaporator should be considered 0.4 and 0.1 in this picture. For the evaporator, 0.4 and 0.1, we can write this relation for evaporator Q plus H4, the difference between kinetic and potential energy related terms are 0. We have H3, H1, the work also is 0. So Q is H4 minus H1. We can calculate H4 calculated before and is minus H1 should be at empty cold vapor. From the tables, at temperature equals to minus 20, we can extract the equals to H. We have cold vapor HG, which is approximately equals to, so Q dot equals to M dot H1 this is H1 minus H4. Let's make a correction. Okay. And part C, calculate the rate of heat transfer from the compressor. Again, consider the picture. We have W dot for compressor is 5 kilowatts from our now, and compressor is between state 1 and state 2 were vapor. State 1 were obtained as H1 calculated above. This quantity called vapor, and H2 is at the information P equals to 1 vapor. And temperature is 50 degrees centigrade. With this equals to, we checking with the table B51. Pressure is smaller than B saturate, so we have superheat. Okay, and checking from B5 to 4, pressure equals to and temperature 50 degrees centigrade, we have H. You can check with the tables. 1. So we can write the relation Q plus H2 minus H1 plus W. H2 is minus H1 W is minus 5. This is the input W and it is minus in the relation. So Q dot NQ and can be calculated. M dot is 1/10 multiplied to this quantity, which is minus Q dot is kilowatt. In the previous example, we can call vapor equals to H at, we should check the temperature and pressure. If pressure greater smaller than P saturate, we should use the superheated vapor. Heated tables, and same as the next, the recent section that we calculated, we review. We first have H1, H2. Should we check it? Table B51, P saturate, and extract the H for this state.